All right, it is time to go over the questions in a video key from the practice questions that you guys are doing for your open book exam on Wednesday. As you can see, I have a million tabs open because that's what my life is, stress. So let's just move on to this first question. Scandium, what happens when you put that in water? Scandium is an element in water. Okay, here we go. In water, elements don't change from whatever they are to start with. Okay, then we have phosphorus. Phosphorus is an element. When it's put in water, it stays exactly the same. Okay, next we have sulfuric acid. Sulfuric acid is a strong acid. I check my acid-base table. It is above the gray bar. It will break up into a hydrogen ion and SO4. Strong acids break up. You might be like, how do I know what it makes? Use slidey finger. Went over that. Okay. Then we have yttrium nitrate. It's not really but yttrium is 3+, nitrate is 1 negative. And this is an ionic compound. Ionic compounds, check your solubility table. So it is soluble, so this will break up into ions. Perfect. Okay, next we have hydrofluoric acid. Hydrofluoric acid is a weak acid. It is below the gray bar. It does not break up. So as you can see, as we're working through all these examples, they all have different rules depending on what they are, right? Okay. Then we have silver chloride. Silver chloride is an ionic compound. Check the solubility table. It is an insoluble ionic compound, does not break up. Sodium carbonate is an ionic compound. Check your solubility table. It does break up. Okay, then we have aluminum sulfate. Aluminum's 3+. Sulfate is 2 negative. So we need 2 aluminums to every sulfate. Checking the solubility table. Sulfate is soluble with everything except for a few exceptions, but aluminum is not the exception. So this dissociates into ions. So a couple just quick review things. I have 3 sulfates, so the 3 goes in front. I have 2 aluminums, and the 2 goes in front. Okay, moving on to some math problems. Can we move this here, guys? There we go. Okay, so reading this question, we've got a bunch of different types of math problems, right? Now I could write out a bunch of different, we'll run out of room, but I'll erase it right now. We've got percentage problems. No, I don't want to sign out. Ugh. What is going? Is it still recording? Oh my God. Is it still recording? Well, I got rid of everything. I don't know why it signed me out. Okay, anyways, so speaking of different math problems, we have percentage problems, we have parts per million problems, we have concentration problems, we have dilution problems, and we have ion concentration problems. So in reading this, does this question talk about percentage? No. Does this question talk about part per million? No. Are we talking about diluting the problem? No. Is it talking about ion concentration? No. So this is a mole per liter problem. Okay. Molar concentration is moles per liter. Okay. So writing down what we know for mole per liter as unit analysis, we have 35.7 grams. We have 100 milliliters. That's 0.1 liters. And what goes with mass? Molar mass. So we need the molar mass of this substance, which is salt, sodium chloride, 2299 plus 3545. Yeah, I got 5844 grams per mole. Okay. I need moles on top, so I'm going to flip that. I saw a couple of people make some mistakes in the work. When you move grams to the bottom, the number goes with it, right? That goes to the bottom. Okay, cancel out grams. 35.7 grams over 0.1 liters. Okay, so dividing that out, 5814 times 0.1. Okay, I get 3 sig fig 6.14 moles per liter. Okay, so you could use this kind of like cheat sheet thing when you're doing questions to figure out what it is. There's only 5 different types of questions that are math based. Okay, all right, reading this one. We've got, all right, what do you think? What do you think about this one? Yeah, so this one is a mole per liter question because it doesn't talk about anything else. So if I want to do the solve for this, we've got 50 milliliters, okay, 46.4 grams. What goes with mass? Molar mass. Now this is a tricky one to do. We've got sodium, sulfate, whoop, that's 10, decahydrate. So our molar mass needs to take all of that into account. So I'm going to do 10 waters. Water's 1802. 10 of those, plus 4 oxygens, plus a sulfur, plus 2 sodiums. Okay, I got a molar mass of 322.25 grams per mole. Okay, and it's the exact same setup as the question above. Flip the molar mass. Okay, grams on top, 46.4 grams over 0.5 liters. Okay, 46.4 divided by 322.25 times 0.05, and I get the 3 sig figs, 2.88 moles per liter. Okay. All right, reading with this.